Hi students, we are going to discuss the dependence of the photoelectric current on the intensity of the incident light. I told you already, whenever you want to study the effect of intensity on photoelectric current, the other factors like the frequency and the applied potential difference must be kept constant. Is it not? We are going to study only the dependence of what photoelectric current and the intensity. So what I am going to keep as constant, you see, keep frequency and applied potential difference as constants. Only the intensity of light should be varied. Okay, how do I keep the frequency as constant? When I say that the frequency is kept constant means how I can keep as constant? The same source should be used. Okay, because the frequency depends on what the nature of the source. Look at the picture and tell me what is the source I am using is ultraviolet source. So first I will keep the ultraviolet source at a greater distance. So the number of photons incident per unit time will be lesser because they have to travel a longer distance to reach the metal plate. So naturally within a second the number of photons incident on the metal will be lesser. So when I keep the source at a greater distance means the intensity I1, the intensity of light I1 will be naturally lesser. In the next case you see here, I have reduced the distance. Okay, medium distance I am keeping. So that since the distance is shorter, within the same unit time per second, more number of photons will reach the metal surface. So that the intensity I2 is greater than the intensity I1. But what about the frequency? Now also same, because the source is the same ultraviolet source. Is it not? Okay. Now the third case, I have kept the ultraviolet source still very closer to the metal plate so that within a second more number of photons will be incident on the metal plate. Okay students. So the intensity is nothing but the energy of the light incident per unit area per unit time. Is it not? The intensity, what is the unit? It is joule per second per meter square. That is watt per meter square. So how do you change the intensity here using the same source of light at different distances? So the intensity means you must remember that it is also equal to the number of photons incident per unit area per unit time. Understand? Shortly speaking, intensity depends on how many number of photons are incident per second, and shortly speaking, the photoelectric current depends upon how many number of photoelectrons are ejected by the metal plate per second. So we are going to relate these two. We want to study the dependence of these two factors. Okay students? Now I will repeat once again. Since we want to study the dependence of photoelectric current only on the intensity of light, the other factors such as the frequency and the applied potential difference between the emitter plate and the collector plate, the voltage between the cathode and the anode, okay, these two are fixed as constants. Then how do you vary the intensity? Also I told you, you are varying the intensity by keeping the source of light at various distances, so that the number of photons incident per second per unit area varies. Okay students, now you tell me I1 is the intensity when the source is at a greater distance. So I1 must be lesser than I2. Then I2 must be lesser than I3. Understand? So first I will study what will be happening when the intensity I1. Okay, I1 means what? Number of photons incident per unit area per unit time will be lesser. So proportionately what will happen? the number of electrons liberated by the metal surface also will be lesser. So, when the intensity is lesser means the photoelectric current is also found to be lesser. So, in which case the more intensity is falling on the metal plate for the intensity I3. And it was studied that for this greater intensity, the photoelectric current was also greater. So, this was plotted as a graph by taking the intensity of light along the x-axis and the photoelectric current along the y-axis. Okay, students. Now this is the graphical study only. So if I will represent the intensity. Okay, this is the intensity of light along the x-axis, and along the y-axis the photo current or the photoelectric current. And it was found that the nature of the graph is a straight line passing through the origin. So what do you mean by a straight line graph? First of all, it is a linear graph. That means the photo current varies linearly with the variations in the intensity of light. The slope of a straight line, okay, is a constant. So this is the nature of the graph. As you go on, increase the intensity from 0. Understand? So the intensity increases means the photoelectric current also increases. So I can write here this photoelectric current. Photo current is directly proportional to the intensity. Okay, intensity of incident radiation, the incident light. Now I have already told you, my dear students, the photoelectric current is also proportional to what? Number of electrons. Okay, so number of electrons emitted per second, per unit area is also understood. So this is proportional to what? Number of photoelectrons. Okay, photons. Okay, number of photons incident per second. So this also is equal to, I can say, because for every single photon incident on the metal surface, one single electron will be emitted. So I can say that the photo current, so therefore the photo current varies linearly with the intensity of incident radiation or incident light. Okay, both are one and the same. So here once again, what are all the important points you should remember is keeping the frequency as constant. How to keep the frequency as constant? By using the same source of light. For example, ultraviolet is the same source of the fixed frequency. Then how do you keep the potential difference as constant? We connect a battery across the collector and the emitter plate, between the cathode and the anode plate. That voltage should be kept as constant. Okay. Then how do you change the intensity of light? I told you we should control the number of photons incident per second per unit area. This is possible by keeping the same source at various distances. Understand? Okay, my dear students. So this is how we are supposed to show the dependence of the photoelectric current on the intensity. Have you understood, my dear students? Shall we go to the next topic? Okay, fine. Thank you.